Okay, the Cartesian equation of a line to its normal. So this is the fourth example. Determine the Cartesian equation of a line passing through point A, which is 4 and negative 2, which has normal 5 and 3. So what we're going to do is we're going to bring out a graph again. What happened there? There we go. Okay. And zoom in a little. We know it passes through point 4 and 2. So that's 4, sorry, and negative 2. So here's our point A. And it has a normal of 5 and 3. So that's over here, 5, up 3. Now, let's talk about what that means. If this is our normal, that means whatever line is going through A has to be, if we're looking for the equation of that line, what relationship does it have to the normal? It is what? Perpendicular, right? So if it's perpendicular, it's going to look hopefully something like that. I think that's perpendicular. So if this could be perpendicular to our normal. So we have our normal here. We don't have any other points along it. We need to get an idea of our point A, or vector A. We need to essentially make up a second imaginary point along this. We need to find another point along this because we need to name the vector. See, our normal vector, we know starts at the origin, so we have 2 points. We know we have 0 and 0, and we know we have 5 and 3. But our vector going through point A only has 1 point. We only have 4 and negative 2. So we're going to make up another point. We'll call it P. And point P we represent it with X and Y. Okay. And we also know, let's go up this a little. We also know that we're going to now call this vector AP. And we know the dot product of vector AP and our normal, or I guess we call it ON, is going to equal what? 0. That's right? They're perpendicular, so the dot product of these two vectors is going to equal 0. Well, we already know what our vector n is, or the values of it. Let's try to figure out what our vector AP is going to be. So let's work on AP itself. Vector AP is essentially equal to, if you guys remember, our x2 minus x1 and y2 minus y1. This will give us a directional type vector for our vector AP. So our x2 in this case is actually going to be our value x, point P. So we have x subtract 4, and we have y subtract negative 2. So we're going to end up with two equations. We're going to end up with the equation x minus 4 for our x term, and y plus 2 for our y term. When we go to put those into dot product, we have x minus 4, oops, and y plus 2 dot our normal. And in this case, our normal is the number 5 and 3. Okay? And we know that it's going to be equal to 0. So we're going to use our distributive property. We're going to end up with 5 x minus 4 plus 3 y plus 2. Okay, when we're going to solve this is equal to 0. And now we're going to put this into our Cartesian form. We have something equal to 0, is why we put it in Cartesian form. And we have a y and an x. And we'll probably end up with some final value c. So when we distribute the 5, we get 5x minus 20 plus 3y plus 6 is equal to 0. That means we're going to get 5x plus 3y. Negative 20 plus 6 gives us negative 14 equals 0. Okay? And just to draw your attention back to this again, remember our normal value was 5 and 3. our form for Cartesian is ax plus by plus c. Okay. So our x value, which was 5, our y value, which was 3, and we had to solve for our c value, which is what we did in this question here.